Winners Tutoring Program. I hope all of you are well. Welcome to Winners YouTube channel. Today we will be dealing with the functions, but specifically with an inverse of an exponential graph. So I want you to listen attentively. Then at the end of the year, your distinction will be guaranteed if you listen very attentively. So we are dealing with an inverse of an exponential. Let's assume you are given something in this way. Then they ask you to find the equation of an inverse. But before we find the equation of the inverse, let's check the shape of this graph. We know that the shape of this graph, the fact that we don't have Q, which means our asymptote will be the x-axis. Then it's an increasing function because the value of b is greater than 1, meaning this value. So if you go back to the introduction, the first part of exponential graph, where I was showing you how to sketch the graph and the possible questions that you can expect, you'll be able to have a better understanding. But I believe if you're mastering the first part, this part will be easier for you. So we know that this point, let's call this point A, the coordinates will be 0 and 1. So we want the equation of an inverse. So to find the equation of the inverse, you interchange x and y. Let's check the inverse. Y equals to x, 2 exponent x. Interchange x and y, 2 exponent y. So after we want to make y subject of the formula, you're going to bring y down, apply the log. Also, you will apply the log this side. You divide by a log of 2. So it's a log of 2. You divide by a log of 2. This will cancel this. Then you'll be left with y is equals to a log of x over a log of 2. Once you simplify this part, after simplifying this part, this thing is still the same as y is equals to a log of x base 2. So do you see that what was carrying exponent, it's now our base now. So something like that. So you must not only know the method, you must also need to know the shorter way. You must understand that if you are given, for example, 1 over 3 exponent x, if they want you to write the equation of the inverse is going to be given by y is equals to log x base 1 over 3. Meaning this thing that was carrying an exponent is now our base. So you can move from here to the answer directly without interchanging x and y. So it's very, very important for you to know that. So to get the inverse, you must understand that to get the inverse, the first thing you need to know the symbol of the inverse. The inverse, its symbol, this part is still the same as this one in the situation for the inverse. So the inverse is given by this symbol, but the original graph is given by f of x. So this is the notation of the inverse. So in this situation, you must understand that in order for us to get the inverse, we must reflect the original graph, which is this f of x is given by f. If you reflect it across this line, y equals to x. This line is given by the equation y equals to x. You're gonna get the inverse. The inverse is this one. So in this situation, I will show you how do you draw the inverse. So the first thing that you need to know is that if they tell you that we have reflected f across the line y equals to x, you're gonna get the inverse. To get the inverse, you must first sketch the original function. Our original function in this situation is this one. So we wanna see how the inverse is going to be. So our inverse, turn your paper this other direction to face the opposite direction, then you tilt it to the right. The shape that you're gonna get for the inverse, you can trace it. This is the shape. So the shape of the inverse will go in this way. This will be our inverse. So if you use the winner's method, the paper method, you won't go wrong. This is called the winner's method. You can only find it at winners. let the paper face you, meaning you sketch the original graph, you turn it, you tilt it to the right. If you tilt it to the right, you must come up with this shape. So we reflected f across the line y equals to x. We got the inverse. The notation of the inverse is given by this. So in this situation, let's check how this point is going to be. This one that was A, now is now point B. So how will this point change? Remember, when you are moving from the original graph to the inverse, you need to interchange x and y. So if we interchange x and y, we're going to get 1 and 0. So it's very, very important. Even when you're given this point maybe as, let's assume you're given this point as 9 and 6. When it comes to this side, it's going to change and become 6 and 9, the interchange on the inverse. So that's how you go about. And another thing, you can see that this and this, they will never touch. This graph of an increasing function and this inverse, they don't have the point of intersection. So check something. To the inverse, original graph, the asymptote was this one. It was the domain, the asymptote of f. The asymptote of f is this one, which is this graph. So our asymptote in this situation is y equals to 0. So that will be the asymptote of f. Let's check the asymptote of the inverse. The asymptote of the inverse. Do you see? It interchanges. So the asymptote of the inverse is now this one. It's no longer the x-axis, it's now the y-axis. So that's now our asymptote, because our graph will just go next to the original, next to the y-axis. So our asymptote, wherever there is y now, you're going to place an x. Remember, when you are moving from the original to the inverse, always where there is y, put an x. So it's now x equals to 0. And it does make sense for the y-axis, for the x to become 0. So that's how you go about in terms of the inverse of the exponential. So now I want us to have a look on the one that is a decreasing function. I want us to have a look on the one which is a decreasing function. But before that, I want you to write the range of the original and the range of the inverse. You need to know how you go about. So let us check the domain now. The domain of this graph, which is f, its domain, do you see it exists everywhere? Which is going to be x element of real numbers. It exists on the positive and on the negative. Let's check its range. Its range, it will only exist above. So it's going to be y must be greater than 0. Let's go to the one of the inverse. The inverse, we want its domain. Remember, the domain will become the range of the original, or the range of the original will become the domain of the inverse. So in this situation, wherever you take this one and replace, remember when we are moving from the original to the inverse, you interchange x and y. So wherever there is y, I just put an x and put greater than 0. And let's check, does it make sense? Remember, we want the domain of the inverse. So the domain of the inverse only exists after the 0. That's why it's going to be x is greater than 0. Let us check the range. The range, you just take the domain. So the domain of the original will become the range. So you just put a y wherever there is x. It's now going to be y element of real numbers. So let's check this one, which is the inverse. Do you find your graph up? Yes. Forever. Do you find at the bottom? Yes, it goes down forever, which it does make sense. So that will be the domain and the inverse of the inverse. That will be the domain and the range of the inverse. So now we are now moving to the decreasing function. Let's check on the decreasing function, how is it going to be? Decreasing function, remember, value of b must lie between 0 and 1. So this will be the decreasing function. Let us check its shape. The shape of the inverse. We're going to start with the original function. Our original function is given by f of x, which is this one. Sorry, we want the one that is decreasing. Sorry about that. We want the one that is decreasing. The decreasing function will go in this way. This will be our decreasing function. So now, here it will always be 1 and 0 if we don't have a q there. So in the situation, we want the inverse of this graph. So to get its inverse, you're going to interchange x and y. To interchange x and y, wherever there is x, I'm going to put y. Wherever there is y, I'm going to put in x. So in this situation, it's going to be x is equals to 1 over 2, then a y. So you want to make a y subject of the formula. You're going to bring y down, a log of half. Also this side is going to be a log of x. So you divide by a log of half. You divide by a log of half. This cancels this. Our y will be a log of x base 1 over a 2. This will be our inverse. So do you see that what was carrying an exponent is now our base? So that's how we go about in terms of finding the equation of the inverse. So now we are now going to how do you then sketch. We're going to apply the Wiener's method in how to sketch the inverse. We're going to apply the Wiener's method in how you can sketch the inverse. Remember, we are having an original graph. You're going to turn your paper to face this direction, opposite direction, then you tilt it to the right. If you tilt it to the right, the shape that you're going to get will be the shape of the inverse. If you apply this method, you will never go wrong. So the shape that we got is this one. So do you realize that these ones, they are intersecting, unlike these ones. This graph and this graph will never intersect, but this and this one will intersect at this point. So that's how you're going to get the inverse. So in this situation, we want to know our asymptote of the original function. The asymptote of the original f is this graph. Its asymptote is going to be y is equals to 0, meaning this will be its asymptote. But remember, on the inverse, the asymptote is no longer going to be the x-axis, it's now going to be the y-axis. So now our asymptote is going to be x equals to 0. Do you see all the time when we are moving from f to its inverse, wherever there is y, you place an x. So that's how it's going to be. So our asymptote is now this part. It's no longer this one, where you always interchange. So you need to master that. So before we conclude our lesson, what will happen is you must understand that once our inverse, the original is shifted, our inverse will also shift. You need to know that. So all the time, what you get on the inverse is coming from the original graph. So basically, these are the things that we know as far as the inverse is concerned. So make sure that you click into our notification button so that whenever we upload the videos that has to do with application, remember today we are dealing with the basic of the inverse. So there is an application of the questions from those basics to application of the questions. You need to know how you go about. So today we are dealing with this. Clicking the notification button, it will help you to be notified whenever we post anything that has to do with the inverse in terms of the questions. So thank you. I believe you are blessed.